Every day we encounter mixtures, whether it's making tea or sorting fruits. But have you ever wondered why and how we separate substances from these mixtures? From removing tea leaves with a strainer to picking out chilies from your poha, separation is a part of our daily routine. In this video we'll explore the fascinating world of separating substances, understand why it's important, and discover the various methods used in our homes and industry. Let's begin our journey by understanding what mixtures are and why separation is necessary. Before we use any material, it often contains unwanted or harmful substances. For example, grains may have stones or husks, and milk may contain cream that needs to be separated. Sometimes even useful components are separated to use them individually. The need to separate arises from the desire to obtain pure, usable substances. Whether it's for safety, taste, or quality, separation ensures we get the best out of what we use. Let's look at some common examples where separation is essential in our daily lives. Handpicking is one of the simplest methods of separation. Imagine a basket of mangoes and guavas. You can easily pick out one kind and place them separately. This method is also used to remove larger impurities like stones, husks, or dirt from grains, rice, or pulses. The process is convenient when the impurities are visible and not present in large quantities. Next time you see someone sorting beans or picking out unwanted items from food, remember, that's handpicking in action. Threshing is a traditional method used by farmers to separate grains from stalks after harvesting. The stalks are dried and then beaten, either by hand with animals or using machines to free the grain seeds. This method is essential because grains are much smaller than the stalks, making handpicking impossible. Threshing ensures that the grains are separated efficiently and can be collected for further processing or consumption. Winnowing is used to separate lighter and heavier components of a mixture using wind or air. For example, after thrashing, the mixture of grain and husk is poured from a height. The lighter husk is blown away by the wind, while the heavier grains fall straight down and form a heap. This method is commonly used by farmers to clean grains and is a great example of using natural forces for separation. Sieving is a method used when the components of a mixture have different sizes. For instance, when preparing flour, a sieve is used to separate fine flour from larger impurities like bran or stones. Sieving is also used at construction sites to separate pebbles from sand. The process relies on the size difference, allowing only smaller particles to pass through the sieve while retaining the larger ones. Dealing with mixtures of solids and liquids, sedimentation and decantation come into play. For example, when rice or pulses are washed, dust and lighter impurities float and can be poured off with water. The heavier particles settle at the bottom, a process called sedimentation. Decantation is the careful pouring off of the liquid, leaving the settled solids behind. This method is useful for separating mixtures where the solid is heavier than the liquid. Filtration is a method used to separate insoluble solids from liquids. For example, after preparing tea, a strainer is used to remove tea leaves from the liquid. In laboratories, filter paper is used to separate fine particles from liquids. Filtration is also used in making paneer, where the solid is separated from the liquid using a cloth or strainer. This method ensures that only the clear liquid passes through, leaving the solid residue behind. Evaporation is used to separate a solid dissolved in a liquid. For example, salt is obtained from seawater by allowing the water to evaporate, leaving the salt behind. The process involves heating the mixture so that the liquid turns into vapor and escapes while the solid remains. This method is widely used in salt production and in laboratories to recover dissolved solids. Condensation is the process where water vapor turns back into liquid water. For example, when steam from boiling water touches a cold surface, it forms water droplets. This process is the reverse of evaporation and is used in separating mixtures where recovery of the liquid is important. Condensation is also observed in daily life, such as water droplets forming under a lid covering hot food. Sometimes, a single method is not enough to separate all components of a mixture. For example, to separate a mixture of sand and salt, you might first add water to dissolve the salt, then filter out the sand and finally evaporate the water to get the salt back. This combination of methods ensures complete separation and recovery of all components. Saturated solution is one in which no more of a substance can dissolve. For example, if you keep adding salt to water, eventually it will stop dissolving and settle at the bottom. This concept is important in separation, as it determines how much of a substance can be recovered from a solution. Heating the solution can allow more of the substance to dissolve, which is useful in certain separation processes. Temperature plays a key role in how much of a substance can dissolve in a liquid. When you heat a saturated solution, more of the substance can dissolve. This is why, in some separation processes, heating is used to increase solubility and recover more material. When the solution cools, the excess substance may settle out again. Not all substances dissolve equally in water. For example, you can dissolve more sugar in water than salt. This property is called solubility and varies from one substance to another. Understanding solubility helps in choosing the right method for separation and in predicting how much of a substance can be recovered from a solution. Let's revisit handpicking. This method is best for separating slightly larger impurities from grains, rice, or pulses. It's quick, requires no tools, and is often the first step before using other methods. Handpicking is limited to situations where the impurities are visible and not too numerous. Winnowing is especially useful for separating lighter husk from heavier grains. The process uses wind or air to blow away the lighter particles, leaving the heavier ones behind. It's a simple yet effective method, commonly seen in rural areas and farms. Sieving is used when the components of a mixture have different sizes. It's commonly used in kitchens and construction sites. The sieve allows smaller particles to pass through while retaining larger impurities. This method is essential for ensuring purity and quality. Sedimentation is the process where heavier particles settle at the bottom of a liquid. This is commonly used to clean rice or pulses before cooking. The settled impurities can then be removed by decantation, ensuring the food is clean and safe to eat. Decantation follows sedimentation. Once the heavier particles have settled, the clear liquid is carefully poured off. This method is useful for separating mixtures where the solid is much heavier than the liquid, such as sand and water. Filtration is widely used in homes and laboratories. Whether it's making tea, filtering muddy water, or preparing fruit juice, filtration ensures that only the clear liquid is collected. The choice of filter, cloth, strainer, or filter paper depends on the size of the particles to be removed. Evaporation is essential for recovering solids dissolved in liquids. It's used in salt production from seawater and in laboratories to recover chemicals. The process is simple, just heat the mixture and let the liquid evaporate, leaving the solid behind. Condensation is the reverse of evaporation. It's used to recover liquids from vapors. For example, in distillation, the vapor is cooled and condensed back into a liquid, allowing for the separation and recovery of pure substances. To separate a mixture of sand and salt, first add water to dissolve the salt. Filter the mixture to remove the sand, then evaporate the water to recover the salt. This example shows how combining methods like filtration and evaporation can achieve complete separation. When too much salt is mixed with sand, not all of it may dissolve in water. This is because the solution becomes saturated. To recover all the salt, more water or heating may be needed. Understanding saturation helps in planning effective separation. Heating a saturated solution allows more of the substance to dissolve. For example, if you heat a saturated salt solution, the undissolved salt at the bottom may dissolve. This principle is used in many separation processes to increase efficiency. Water dissolves different amounts of different substances. For example, more sugar can be dissolved in water than salt. This property is important in separation as it affects how much of a substance can be recovered from a solution. Let's summarize the methods we've learned: handpicking, winnowing, sieving, sedimentation, decantation, filtration, evaporation, and condensation. Each method has its own use depending on the properties of the substances to be separated. Often more than one method is needed for complete separation. Separation methods are not just for the kitchen or classroom, they are used in industries, laboratories, and even in water purification plants. From obtaining salt from seawater to cleaning grains for food, these methods play a crucial role in our lives. Did you know that the process of winnowing has been depicted in famous art? The Winnowers, painted by Gustave Courbet in 1853, shows people using this traditional method. It's a reminder of how deeply these processes are rooted in our culture and history. Separation of substances is a vital part of our daily lives and industries. By understanding the properties of materials and choosing the right methods, we can obtain pure, useful substances from mixtures. Whether it's for food, water, or industrial products, these techniques ensure quality and safety. Next time you see someone straining tea or cleaning rice, you'll know the science behind it.